Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, episode 19 of 24. You want to add voice generation to your app, but writing custom integration code for every single provider's audio format requires constant maintenance. Every time you switch from an OpenAI voice model to a Google voice model, the required JSON fields, the API paths, and the audio return types completely change. The mechanism that resolves this is universal text-to-speech using the LiteLLM audio speech bridge. Instead of maintaining separate API clients for OpenAI, Vertex AI, and Gemini, you standardize your application on a single format. LiteLLM exposes a unified endpoint that exactly mimics the standard OpenAI audio speech route. You construct a request containing your text, your chosen model name, and a voice preference, sending it to LiteLLM as if you were talking directly to OpenAI. The gateway then translates this standardized payload into the specific format required by your target provider. Here is the key insight. Many AI providers do not offer a straightforward, dedicated text-to-speech API that streams audio files out of the box. Depending on the provider, accessing a voice model natively often requires routing the request through a generic text completion endpoint. You might have to pass highly specific configuration flags, send a complex system prompt, and then extract base 64 encoded audio strings deeply nested within a JSON response. LiteLLM abstracts this entire translation layer. It handles the API negotiation, unpacks the proprietary response structure, and isolates the actual audio data. Consider a concrete scenario. You decide to generate spoken audio using Google's Gemini Flash TTS preview model. In your application code, you point your standard HTTP client to your LiteLLM proxy URL at the audio speech path. You set the model parameter to point to the Gemini Flash TTS model. You assign your plain text to the input parameter, and you specify a valid voice identifier. When you execute the request, LiteLLM intercepts the payload. It securely authenticates with Google Cloud or Vertex AI depending on your setup. It repackages your plain text and voice selection into the specific JSON schema that the Google API demands. When the Google model processes the text and returns the result, LiteLLM intercepts the proprietary response. Rather than forcing your client application to parse a custom Google Cloud payload, LiteLLM extracts the raw audio bytes. It seamlessly bridges the transport layer, immediately streaming a standard MP3 file back to your client. Your front-end or back-end application receives a standard audio stream, completely blind to the fact that the underlying generation was performed by Google instead of OpenAI. This bridge logic means you write your text-to-speech client integration exactly once. If a new faster audio model is released by Vertex tomorrow, you only need to change the model string in your request. The application code handling the MP3 stream remains entirely untouched. Treating audio generation the exact same way you treat text generation allows you to standardize your application logic. By forcing all text-to-speech requests through a single unified interface, you can route, load balance, and set up failovers for your audio generation across entirely different providers without writing a single line of provider-specific fallback code. Thanks for listening. Happy coding, everyone!